Okay, everybody, we're going to start class, and it is a Monday again, and we're doing engineering management as usual on Mondays. And here we are. We have last time I started this lecture, and I thought maybe I would finish it and then move on to another subject. We're talking about ERP systems, and let's see what we've got here. The lecture is lecture number 10. I got about halfway through it and ended up, I don't know, somewhere around here. But it's kind of weird to start in the beginning. It's kind of weird to start in the middle of a lecture. So I'm going to kind of review what this lecture was about. And it is titled Enterprise Infrastructure, Metrics, and Business Continuity Planning. So I was talking about business continuity. I haven't actually talked about business continuity planning yet, but that's a term you're going to want to be familiar with, as well as sustainability and building sustainability inside the company. Continuity planning is keeping the business running when all else fails. When we have a natural disaster, when we have, I don't know, a problem with the economy, we have a competitor who comes in and takes over. We have something happens and it's continuing the business without failing or without going broke. It also makes sure that you're actually able to do the business tasks of the organization in light of, let's say, a power outage or a network failure or something of that nature as well. So the term actually goes way above and beyond staying in business. It's more like continuing the business practices for the most part. All right, and ERP systems have a tendency to help out in that area. I went through the beginning of this already, but just to kind of orient you to a few terms here, we have the service-oriented architecture, which is part of the infrastructure. In fact, that's more of today's way of going about getting your business systems is to build the architecture, and it's more of a service-oriented software as a service. We have services that provide software abilities, software and hardware most of the time. And an example of that would be like Salesforce.com, which is a very popular service-oriented software package or architectural package that you can use for Salesforce, to support your leads and lead generation and marketing efforts, and capturing new customers, new clients into the system. If you're not familiar with that, anyway. So the concept here, looking at and extending it out towards the entire organization, and leading to more of using agile techniques of using resources in their best ways, and proactively in addressing changes in the market, things of that nature as well. So software, service-oriented architecture, software as a service, and more of the cutting-edge, latest technologies enable a company to not only be more agile, but also to be more competitive in terms of what they're offering, and also be a little bit more knowledgeable. Haven't talked about knowledge yet, but we'll be talking about knowledge probably today in the next lecture. It's the next topic coming up in terms of making a knowledgeable company and using knowledge as an asset as well. So I went through this already, but I wanted to kind of review the concepts of what I've been talking about so far in this lecture. The hardware, the software components of it. The IT infrastructure itself is a component. So it's the structure beneath the structure. This is the infrastructure. So it's the IT infrastructure is implemented on the organization's architecture depending upon what you're working with. We looked at client-server distributed systems in terms of those types of architectures. You don't have to be a network professional, nor do you have to know anything about technology to understand these different concepts and terms. And if you're working in this area, you certainly do want to have some familiarity with what's a decentralized versus a centralized network, what's a client server, what's a peer-to-peer, what's a distributed kind of system. Because you're going to be making decisions in terms of purchasing them or supporting them or recommending them for the organization. So I believe I talked a little bit about as well the ERP concept, Enterprise Resource Planning. And that's the collection and integration of everything put together: accounting, finance, supply chain, inventory management, customer relationship management, all these other buzzwords put together. They're more than just buzzwords, they're concepts, and they're also the way that people are conducting their business and supporting their business functionality electronically or through communications. It's big business in the US. Actually, it's big business elsewhere as well. I talked about SAP and PeopleSoft and how that works with that as well. SAP being the dominant ERP provider right now. PeopleSoft is, I would say, probably second second best maybe at this point. We have some other people though. We have some other companies that are coming into the business, so it's not going to be dominated forever by SAP. But then, it's a good area for jobs right now. And then, as I mentioned last week, it's one of the things we offer here at ITU as well, SAP certification. So not a bad thing to study if you want a quick internship kind of thing going on with that. Because a lot of people don't take the time to learn the middleware. SAP is nothing more than a middleware application, keeps things together. So it's kind of a different concept. It's not what I'd call hardcore computer science, nor would I call it software engineering. I'd call it business services, actually. So you can have a pretty broad background and get into that area and do just fine. In terms of the evolution, we went through this as well, looking at different from the 1970s. You don't have to know the history of ERP or the evolution, or you don't have to know anything about SAP or PeopleSoft or anything like that either. The idea is to give you some exposure to the concepts and the terminology they use, as well as the software packages and tools that are available. So if you heard SAP, you probably know, oh, it works with ERP systems. Oh, yeah. Well, also, and what does ERP systems work with? Customer relationship management, Salesforce automation, manufacturing, supply chain management, all that stuff that all works together in an enterprise kind of environment. And the one thing I didn't mention today yet is about the benefits of the ERP system. They outweigh most of the problems with them. Problems being, for the large part, a lack of understanding of what the ERP system is supposed to do. And also the problem with, if you think about the concept, a brand new startup business isn't going to install a huge ERP system in their first year. Instead, they're going to build all of their processes and all their business tasks separately. And it's going to be, whatever it is they happen to require as a necessity. They may not necessarily be doing all the functionality of a big company when they're in business for the first year. So it doesn't make any sense, especially when these ERP systems cost, hundreds of thousands of dollars, to go out and buy one in your first year of business. It doesn't usually happen that way. So what ends up happening is the transition to the ERP system becomes the nightmare, because the company has survived to a certain point, and then it's decided that, oh, hey, we need an ERP system now, or maybe we should go the ERP route, and then it's making the transition, not only transitioning the data, but the business processes and the way the company actually functions has to be retranslated or reformatted to fit the ERP systems, which is kind of an issue when you think about it for a big company these days. So the biggest trend actually that's coming out now is don't own the system, don't spend the $200,000 to buy the ERP system in your first year. Instead, start licensing out pieces of a service-oriented architecture or software-oriented architecture where you can just buy licenses or seats on an existing system, so you can build your company from the get-go using an ERP kind of component, and then just keep growing with it. And then you don't have to go through that suffering through that transitional period. You're already built for the long term. Obviously that's kind of a commitment in the beginning. But who opens up a business without a huge commitment? I mean, you're not going to open up a business thinking you're going to go broke, and you're trying to save as much money to recover your losses, which is kind of counterintuitive to being successful in the business. So a better way of looking at it is more along the lines of, well, how do we grow? How do we become what we want to be, but do it in stages? Where service and service-oriented architectures really come in and play a big part today, because it opens up the door, essentially. So you plug everything in, and you have these plug-and-play components, and you use what you need, and you add on what you don't have as you continue to grow the business. And then eventually what ends up happening is you end up with a full-featured infrastructure that looks good and works well for the company organization. Now, if we look at the infrastructure itself, and here's a sort of a comparison of the two working together, you can replace this in-house developed software. You can replace in HR, and this is an example here in this slide, with accounting, sales, HR, CRM. They're all components, so you can plug and play and replace and use something locally or house something through a service, which is kind of the approach to growing quickly these days. So if you don't want to buy it, you service it, and you have that serviced out, and then eventually you bring it in if you want to bring it in. Some people don't. they just leave everything serviced out. So, which is kind of, sort of like the way insourcing, self-sourcing, and outsourcing is sort of working these days as well. You don't necessarily need to bring in payroll or HR or CRM or supply chain or anything. You might just want to contract it out through another company. And then as a business concept, what you're looking at then is at the flexibility. So then we've got this far as well, looking at some of the advantages and disadvantages. So as a service-oriented architecture, looking at reliability, actually, the information and its accessibility. It's going to be reliable. You're not dependent upon your local IT staff to maintain and support a server. So if it's a service and the service goes down, generally there's a big company that's supporting that server. So they're going to have, hopefully, they're going to have the technical expertise to bring that server back up. If it goes down a lot, maybe the company should consider switching service providers. And if that's the case, then the new service provider is going to hopefully have that expertise. So it's not something you have to worry about internally. Small startup companies don't have huge IT staff, long story short. Avoid data and operation redundancies. Yeah, if you get everybody working on the ERP system in the beginning, you don't have everyone capturing the same data, storing the same data, and you don't have all that stuff to sort out, which is kind of like what I called all of the transitional stuff. You don't have to sort everything out. It's already sorted out for you. Delivery and cycle time reduction, cost reduction, easily adaptable, easily growable, probably not on this, maybe it is on the slide, yes it is. Improve scalability. So scalability is referring to the ability to grow it. So if you don't have 100 salespeople, you only have 5, 4, or 1 salesperson in the beginning, you can grow it out, scale it out so that it'll support what the company needs further down the road. And then also e-business support, so you're automatically electronic. Some of the disadvantages of going this route, time consuming. Yeah, actually it is. It's a lot easier to open up your doors and do business without going in the ERP route in the beginning. This could cause a little delay in the uptime of all of the tasks and things that are being done by the organization. It's going to definitely be a learning curve for people who have never used an ERP system before. So the time might be might be time consuming, may also be very expensive, more expensive than going the Microsoft Office route or the non-ERP route, just going the low-tech route to doing things. Lack of conformity of models as well. And these are modules, excuse me. The modules being maybe the HR model doesn't conform to what you guys want to do. Maybe you have employees that don't fall into any of the roles or categories or anything of the existing kind of system. So it might not necessarily meet, the format that way you're going to do business. Also, vendor dependence. That's the biggest problem, which is why probably SAP is very popular these days. Once you get on it, you can't get off of it. Everything is going to be on that same platform from the same vendor, from everything. So what ends up happening is you're kind of dependent, and then what ends up, the prices go up or the performance goes down, or, let's just say the availability of a particular module that you need is not there. There's going to be a problem eventually, and you're going to end up with having to either switch the entire platform over to a new vendor, new OS or something, or just dealing with it and taking a hit on performance because of those problems. May also have too many features and things you don't even know you need yet. It's like when people buy, actually, believe it or not, it's like in the beginning when people used to buy cell phone service. All a bunch of stuff. It's like how many people actually knew what they had. Now you know, but now you're more particular as you grow as a cell phone user. But your first cell phone or two, you probably didn't realize the package you were getting in terms of what was the coverage, what was the roaming fees, what was this, They've made it a lot simpler, but there was a lot of features in the beginning of a lot of services, actually. Maybe too much complexity, questionable scalability, not enough extendable ERP capabilities. Maybe the system doesn't have the capability of doing what you need it to do. So, okay. And then I stopped, I believe, talking about the supported network infrastructures last time. If not, this is where I'm going to pick up. So, we have the computer network. And you don't have to be a telecom major, or you don't have to know anything about telecommunications to be familiar with the different infrastructures related to this. So here's the underlying infrastructures for any IT environment: the decentralized, the centralized, the distributed, the client server, and the tiered. So decentralized network infrastructures involves little or no sharing of IT and other resources. So you're more of a medium-sized company, or actually a lot of small companies do start out networked to begin with. It depends on where the people are located. If you're all in one building, you're not going to have very much of a network. If you're not, you're going to end up starting to realize, well, all right, I need to figure out how I'm going to organize the network. What am I going to do to provide the computing services among all the divisions to facilitate the communication that I'm going to need to go on in the data exchange? And how are we going to do all of our jobs as these remote distributions, so centers, or this decentralized area? So decentralized is all over the place, almost non-existent today. As I mentioned last time, it doesn't work because everything's all separated. What do we want? We want everything put together. So we want everything supported by a centralized server of some sort. We're not going to keep it all separate, which is why it almost doesn't exist today. And this is an example here of it just within a company. Imagine if you have multiple company sites, then you're going to look at a decentralized structure for the entire organization. So you take your target stores and you decentralize them. And that's good for the local network, but eventually you're going to have to put it all together. How are you going to know what one store did versus another store? How are you going to share information across the departments or across stores? So here we have a finance department, a marketing department, and a shipping department, all separated and on islands of their own, which is not really the most optimal idea. You want to put it together. So here's your centralized network infrastructure. So you're sharing information on one central area or on one central mainframe. So now you're going to put it together. So like it's almost non-existent today because for different reasons. So in the decentralized, everything's all separated. Can't have things separated. Want to put things together. Centralized says, okay, let's put it all together. Problem with putting it all together is now you have one point of fault. The server goes down, all the stores in the entire United States are down. And then you also have connection problems. And what if the centralized server is located on the West Coast and you're on the East Coast or something? You know, you have latency, you have bad connections, you have a single point of fault where you're not going to necessarily be able to support everything. Plus also you're relying on one server. What if the company grows? So what you're going to end up having is a combination. You're going to have a distributed network. So distributed network distributes the information, the processing power, and everything across different networks. So the first true network infrastructure, and it's also the way that the internet works actually. So the internet is only as big as it could get, or it actually grows every year. But it's gotten to this size because it is distributed. It's not relying upon one network system, and it's not decentralized, not centralized. It's all over the place. So if you build your company infrastructure to be distributed, then you'll have better scalability in the future, better connectivity, fewer problems. It's using the internet as the infrastructure model. Doesn't necessarily need to use the internet. We could do private networks instead of the public network and accomplish pretty much the same tasks or same goals. Cheaper companies will do the public network because it's available, whereby setting up a private network might not necessarily be as affordable to a smaller startup. So in the terms of the distributed network function, this is what we looked at last time with the Denver office and New York office, and here's a Dallas office. Putting it all together and separating everything out. A lot of companies actually locate core services at different locations. So in this particular case, the New York office might be doing the HR or might be doing the customer service or something. And then the Denver office might be doing research and development or something. Or, Dallas could be doing the manufacturing effort. And then we could have another location at an outsourced area which is actually doing the manufacturing. So then, have them correlate back and forth with the with the supply chain management and other activities. We also have the client server infrastructure. I mentioned this last time as well in terms of the description. So this is the network where we have one or more computers that are connected together. This is not client server, this is distributed, but it can also be defined as a client server when one server acts like a client to another server. So the terminology is just basically outlining the architectural structure. We don't necessarily have too many client-server relationships that stand off on their own that are not connected to a distributed system. Classic example, every single person who's connected to the internet right now in this classroom is a client. So we have a client server. You're connected to the ITU, probably the Wi-Fi system, I would hope. If you are, that's the server. So you're the client, that's the server. You have a client-server relationship, but you're on a distributed network. So that's where the terminology comes in. So what you want to do is you want to be familiar with the terminology. Because we're at the halfway point in the course, I can probably tell you what's going to happen for the final exam. And I'm going to give you questions, and the questions are going to be on different topics. And one of the questions is always on networking and infrastructure, and basically describing the differences between, let's say, client-server, distributed, I don't know, centralized, and all of the different peer-to-peer, all the different kind of architectures. That's just one option. What I'm going to do for you actually is give you like 20 questions and you only answer 5 of them. You pick the 5 you want. So if you like networking, you can answer that question. If you don't like it, you don't have to answer that question. There'll be another one on ERP, and there'll be another one on different things that I talked about in the course. But if you are, I do actually usually have something on the network infrastructure. So if you do have an interest in it, and it's going to be more along the lines of comparing and contrasting different types of systems together, which is kind of like what you're doing as an engineering manager when you're trying to determine how we're going to connect the offices, if that's your job, if you're working in this capacity. So anyway, clients and servers, they work together, they optimize processing. When you surf the internet, the underlying network infrastructure is a client server because you're a client, you're connected to a server, the server is connected to another server. One of the servers is acting like a client, the other server is acting like a server when they exchange information back and forth. So here's a picture of what the client server looks like. Here's a bunch of clients, and you're connected to, let's say for example, a database server or an application server, a web server. This is what they call a tiered server environment. Most companies are tiering things out these days because you don't want to stick it all on one computer system. Not only is it going to be slow and you're going to run out of room, but for architectural standpoint, it doesn't make any sense. It's better to break it all out, tier it, and then you have better scalability, but then you also have better segregation and kind of specialization in terms of what the server is doing. And then this is just one application server and one web server. If you're Google, you're going to have thousands of web servers, thousands of application servers. You might actually just have one of each category. In fact, this is a pretty standard 3-tier configuration actually, where we have the public web interface to the web server that connects to the application server connects to database servers. Database servers actually connect to databases. So the database server might actually just be hosting up the various different databases. We put it all together in the actual raw data that's being stored, and then we can share it out among all the different applications. Which is kind of interesting because you take something in on an email message if you're Google, they're mining your email. So if you have content in your email message that's stored in the database, well then another application out there can use it on the Google server to send you ads or to, I don't know, sell your data or do something with it to make it so it's usable, as I should say. So in terms of the tiered, what I'm describing here is a network tiering, as I mentioned before. Some people call it an N-tier environment. Some people call it a tiered or a layered environment. Another component of the infrastructure to be familiar with. So it's partitioned into layers or tiers or servers that perform specific functionality. Each server has its own job. So one tier is one single machine that has everything on it. A 2-tiered is the basic client-server relationship. The 3rd tier is to have one client, one application, and one database server, sort of like this. This is a 3-tiered system, as I mentioned before. And then we have people that say, oh, it's N-tiered. So it means that you have multiples. This is a 3-tier. If I only have one web one application, and then I've got a 3-tiered system. N tier would have many web servers, many of this, any number, or N. So scalable 3-tiered structure with more servers. So that's generally how the terminology works with that. They say, so if it's N-tiered, it's usually some sort of a 3, possibly a 4-tiered system with multiple servers on each one of the tiers. So in terms of our presentation, our application, our data, our business, and this is looking at, sort of the way that the tiers are labeled these days. It doesn't have to be. You can actually organize your tiers any way you want. It doesn't necessarily have to be organized this way. It's just an example. So one of the things students hate to do is actually think out of the box, come up with things on their own. So one of the questions I like is actually, when, especially in a software engineering course, is to ask a student, design the tier system. And you see they go to Google and they look up this stuff and they go, oh yeah, web tier, application tier. And I'm like, you know what, I don't know if I would have done it that way. And a lot of companies don't follow the 3-tier model, actually, because it doesn't make any sense sometimes. What do you need a web server for, especially when you don't have a public interface? It's just an internal app or an internal program. So you can kind of, with the tier, and the reason why I'm bringing this up as an example is that there's flexibility. There's no one model, actually, that works with all situations. It's not a textbook answer. It's more like a creativity answer in terms of what are you going to do to meet the needs of the organization, which is actually kind of funny because you get a bunch of managers in here who don't study technology, have no concept of engineering at all, of any sorts. And then they start designing the network system. And then somebody else comes in after them and go, why in the world do we have a web server for? Well, what do we have this database server for? We don't even use the database of this company. Maybe we should be, It's just the logic, it's kind of lost in translation between consultants who sell business systems and business people who buy them. It's actually kind of interesting how that works. Well, if you didn't know anything, then you're going to rely upon the knowledge of the salesperson, and if the salesperson is going to try and sell you as much as possible, you're going to get a lot of stuff you don't need, long story short. Anyway, IT success metrics. How are you going to measure, how are you going to know if you have too much? How are you going to know if you don't have enough? How are you going to measure the success of your configuration or whether your IT computing is actually working? Well, one of the biggest things is benchmarking, but people don't think about benchmarking until after they've already made the changes. And then they go, oh, maybe we should have benchmarked it. So if you're going to do this, this is the way to ensure promotion and advancement in your career. Show that you've made a positive result. If you can't show any positive results, you're not going to go too far in your career. You're probably going to end up switching companies a lot more often, actually, because management's not going to want to keep you for too long. So if you're in a management position and you're actually trying to stay there and grow in that position, you're going to need to show that you've actually done something successfully and that your system actually works. In order to do that, you have to show metrics. In order to do that, one of the best things to do is do benchmarking. So a lot of people forget is that if you started out, for example, you're going to take and you're going to convert all the Target stores over. You're going to change the infrastructure. They hired you in. You're going to create a better infrastructure for them. You're going to improve the system. Or a Fry store. Let's just take a big retail store because most people are familiar with retail for the most part. So first thing you would do is benchmark the current standard. How many sales are being performed per hour? How long does it take for the average transaction? Oh, are we going to do attendance?
Oh, we are, but can you announce it?
Sure. I record, so hold on one second. Let me just pause this. No, it's good. All right, so let's get back to measuring metrics. We'll take attendance later. So in terms of the IT success metrics, as I was mentioning before, benchmarking is not a bad idea to give yourself the before. So in terms of benchmarking, what a lot of companies don't do is figure out, or a lot of managers, because I'm giving you advice in terms of you want to be promoted in the system, you want to actually look good, you want to show good job performance. So the best thing to do is pick the core competencies or pick the success factors. Sometimes they call them critical success factors. Sometimes they call them core competencies. Sometimes they call them just factors. And benchmark those factors. What does this mean? What's important to the company? Is it going to be sales information, sales per hour, transaction, cost of the transaction, cost of actually performing a transaction, you're going to go into, and my example I gave you was going into, let's say, a Target or a Fry's kind of store where you're working in a retail environment. Cost of the sales transaction is actually kind of a good benchmarking factor to do. Time, speed, customer satisfaction is also good in that outlet. So you pick the success factors that lead to a better bottom line in terms of what it is you're going to actually accomplish and how you're going to show the improvement of that accomplishment. So you benchmark it. Benchmarking is nothing more than getting some numbers. Okay, it takes us 5 minutes to ring a salesperson up. And it takes us 10 minutes from the time the customer walks into the store and by the time the customer comes out of the store. You get the numbers, you get the facts. If you're doing it on something that's not important, it doesn't really matter how well you improved it. You know, if you say that, oh yeah, we're saving electricity, who cares about that or something? You know, it's maybe the company doesn't care about that. So you pick the nice factors, you benchmark it, you baseline it, you put the new system in, you change the network, you upgrade the service, you do something that is your decision in terms of what it is you're going to change, and then you benchmark, you measure it again. And when you measure it again, you can show that now we cut the customer transaction time in half, or we've reduced the cost of the transaction by 20% or 30% or something. And you show the metrics. So these are the types of metrics that actually keep you employed. They actually get you promoted. They actually make you look better than someone else who can't show any results or is not producing any results. Because just because you're not showing results doesn't necessarily mean you're not producing them. So if you're going to produce them, you might as well show them, right? So anyway, that's kind of an interesting concept. You see a lot of managers a lot of times don't actually get credit for their work because they're not, and that's actually kind of the harsh reality of life. You're not going to get credit for your work unless you make it, you know, unless you actually ask for credit for your work, you're not going to get credit for your work. And if you don't ask the right way, and if you don't show it the right way, you're never going to get credit for your work. Somebody else is always going to get credit for your work. So, and it usually happens a lot with engineering and engineering management, actually, because you're not necessarily bringing in more sales for the company. You're not showing in what the product is. You're not working with the product development sometimes. You're not working with, you know, maybe you're just improving the manufacturing. You're making a better product. But if you're not going to show that, then you're not going to ask for any recognition. You're not going to get any recognition, long story short. And then you'll leave, and then later, you know, a year down the road, they go, how come we were doing so much better back then? You know, hello, because, you know, your best people just left. So, anyway, justifying the cost of the technology, you need to measure its success because it's not going to be measured in the output of the organization in terms of the bottom line sales numbers or number of students or number of whatever. Not always shown in the output of the organization, but maybe it's better satisfaction or maybe it's you know, more returning customers or something. So benchmarks, baseline system. Benchmarking is the process of continually measuring the results and comparing them to the benchmarks. So are we still improving? Are we not improving? People who fail to benchmark have a tendency to go downhill. And when they slide downhill and they go down into negative, they just keep dropping. They never pick themselves back up because they can't tell that what they're doing is causing problems. If you put a new system in, you don't benchmark it, you don't continuously benchmark. And then you notice that, oh look, people are becoming less efficient. Now it's taking 20 minutes for that one sales transaction to actually be completed. Oh no, now, and then it gets worse and worse and worse. You don't know to pull the system or to stop the program or stop the system, which is actually a better decision than actually putting it in to begin with. That's a problem. So efficiency and effectiveness. Efficiency is doing something right. Effectiveness is doing the right things. It's kind of like validation and verification in software engineering. You have to have both, actually, for your solution to be a good solution. Efficiency in the least amount of time, lowest cost, fewest number of errors. And it depends on the company how you're going to measure the criteria that you're going to benchmark and what you're going to look at. And as again, it goes into the core competencies or critical success factors that are identified. In terms of the effectiveness, getting the customers to buy when they visit your site or your store, answering the right questions with the right answers the first time, things of that nature. So if you look at this, we have things that are associated with bottom line and top line. In terms of high efficiency, such as a customer's, you know, supply chain management system, or top line, So you can actually kind of, if you go bottom line, top line, I don't know if I've talked about this in this class yet. Let me discuss that for a few minutes here. It's kind of like the glass is half empty or the glass is half full. You know, are you looking at the top of the glass? Or are you looking at the bottom of the glass? But it has nothing to do with perception of some optimism or lack of optimism, which is what the glass is half empty and the glass is half full means. It means, are we making more sales? And are the sales coming in on the top line? It's the customers, it's the sales, it's the output we're seeing from the external part of the company versus the internal part of the company, which is the bottom line. We need to improve our business to make a profit. We can make a profit in two different ways. We could sell more product. That's the top line. Or bottom line, get rid of most of our overhead, cut our expenses, make a cheaper product, sell it at the same price. So top line strategy says we need to make more money, let's raise the price of our product. Or let's sell more product. It's all external factors to the organization dealing with making more money as the goal. If we didn't deal with the external, we work with the internal. The bottom line thinking is let's build a better IT structure. We build a better IT structure in this particular example. We reduce our overhead operating expenses. We're making more money on the product we're selling. We can sell the same amount of product and we can make up that money. We can get that money that we need to make our profit using a bottom line strategy. So bottom line strategy is all about overhead expenses. It's all internal changes to the organization to improve our operating, to improve our processes, to make our people more effective, more productive, to make our product cheaper, you know, improving our supply chain management, improving our pricing model in terms of our parts, our manufacturing effort, getting more product produced faster, cheaper, all focused on bottom line. Engineering managers focus bottom line. Business people focus top line. All they're worried about, well, I shouldn't say this is trivial, but the stereotype for an engineering manager type of position, it's all bottom line. You're going to make the company more profitable by improving the telecom system, or by improving the manufacturing process, or by working with the engineers to make a better product, or changing the R&D around. It's all internal. It's all internal structure. Business people that work with top line, on the other side of the fence, they're trying to sell more product. How do we reach a bigger market? How do we sell more product? Or how do we change or offer a different product? You know, how do we offer what the people want? How do we make the customer happy? How do we do this? How do we do that? So it's kind of like two different ways of thinking. So it's like kind of like the glass is half full and the glass is half empty. But it's a strategy that you're looking at. Most of your engineering efforts bottom line. And so you're producing, and if you're not going to show your bottom line results, the top line is going to take it for granted. You're going to go, oh, we're making more money now. Oh, wow, then our salespeople must be doing great. No, we just cut your inventory in half and got rid of that warehouse you didn't need, so now we don't have as much overhead per month, so yeah, we're making more money. But, you know, it's like, who's going to get credit for it? Salespeople most of the time. Business people are going to take the credit for it. So that's what I'm trying to tell you. Unless you share the metrics to say, Nick, we're saving the company so much money now. This is why we're more profitable. So a lot of companies actually don't know why they're losing money, and they don't know why they're profitable. It works both ways. They go, oh, we're just lucky. We're making a lot of money. There's no luck in this. It's not that you're lucky. It's that, or why are we losing money? It's because you're not spending it right. It's like people, actually. If you think about people's own personal finances, there are some people in, let me just take the stereotype of America lifestyle, because you guys won't be able to relate to this, but you might find this interesting, actually, because you come from a totally different background. See, the American lifestyle from the 50s, let's just talk about older, because it's changed throughout the last 20 years or so, but go back to the 1950s. You could actually work without a college degree in a retail job, making minimum wage or a little bit above it. Buy a house, get your 2 cars, your 2 kids, your dog, and your retirement. If you spent everything correctly, if you worked correctly. So some people actually did that. And then other people complained, it's not getting me anywhere. because they were not, they were top line people, they weren't bottom line people. Bottom line people can buy a house and retire and do all that stuff on a minimum wage job. Doesn't happen today. You can't, well, it's harder to do it. There's some people in the Midwest that actually accomplish this though, but they're bottom line people. The top line people spend all their money on stuff that they shouldn't be spending it on. They're not saving any money, they're not doing anything, they're not investing in their future, they're not doing anything. So they're the ones who complain about it, and they can't actually succeed. So, and I'm sure even in your culture, where you know the lifestyle, you can tell there's bottom line, top line kind of thinking. But usually, people that go to college are bottom line thinkers. They're not. If they get $1, they don't spend the dollar just because they got $1. That's a top line person. Top line thinking. I have money in my pocket. I'm going to spend all the money I have in my pocket till the money's gone. So what about saving it for a rainy day? No. So that's a bottom line thinker. How do we reduce? Why am I paying so much in rent? Why is my cell phone bill so high? Those are bottom line kind of thinkers who will reduce the bottom line. So if you relate it to real life, you'll never forget what that means actually. But it's reused all over business, and it's all over business classes. People go, your bottom line, the bottom line, and they go, what in the world is that? There's actually a meaning to it. So anyway, types of successful matrix here: infrastructure, web, statistics, web-centric metrics. These are kind of deceiving these days, actually. Call center, financial metrics. So in terms of your infrastructure-centric metrics, looking at measuring efficiency, speed, capacity, and technology. Does it really matter how fast the network works at ITU? No. Does it matter that we can get on the network? Yes, that matters. But it doesn't really matter how fast it works, really. People would be happy if it just worked, actually, for the most part, which is actually kind of interesting phenomena. Does it happen out in industry? If you're at a Starbucks, does speed matter? Yes, it does. Faster speed is going to matter. So, wow, we're doing construction here? All right, throughput, the amount of information that can pass through the system at a given amount of time. These are ways of measuring the infrastructure. Transaction speed, the speed in which the transaction is going to complete. System availability, that's a huge one. Is the system available from an infrastructure perspective? If it's not available, people can't use it. It's not going to provide very much of anything to measure, really. Accuracy. That's an important one if you're a Wells Fargo bank or something. Or you're a bank. I keep saying Wells Fargo. If you're a bank, then accuracy is like the #1 metrics that you're going to need. Also, response time. That's good too. When you make a deposit, did your deposit actually post? And do you have the funds available to you? And was everything checked and cleared on time? Scalability, not such an issue. They're already built for scalability. If you're a small mom and papa company trying to make sales at a art and wine festival, scalability might be something that you're going to measure, because are you going to be able to service customers out in the middle of a park, or do you have to have a landline service for your transactions to actually work or something? In terms of web-centric metrics, these ones I hear I say are kind of deceiving, because there's little games with clicks and things, you know, and you can sell Google ads and do all the stuff, but long story short, it all breaks down to why is someone clicking on something versus are they clicking on it because they want to come to your company. So this is pull versus push kind of strategies, web marketing, website optimization, search engine optimization stuff. It's important. Makes sense for top line people to bring customers in. So web-centric metrics is also another category of metrics to measure the successfulness of your e-commerce website. Total hits, page exposures, conversion rate. Also looking at click-throughs, clicks per 1,000, abandoned registrations, abandoned shopping carts. This is actually an interesting one. They've done some studies recently, and I was recently reading something on an e-commerce website, metrics, not a metrics, it was I can't remember the theme of it, but long story short, the company can learn a lot by how many people got halfway through the shopping cart and abandoned it, or how many people actually waited and then put everything in the shopping cart and bought it all at once. So it's like, it has something to do with the trust of the company, the pricing of the products, and the design of the website, actually. So you can design your website so people never buy anything. You think about it, it's like, well, what is an e-commerce website, but they're not buying anything? So you put up like 5 different websites and test it, and you can go, well, this one is actually doing better than that one over there and that one over there. They're all the same location. They're all on the internet, but maybe one has different wording on it, or one has an easier interface, or a more intuitive interface, or maybe one just wants people just want to buy on that website and they don't want to buy on another one, which is actually kind of funny if you think about what happens on eBay. If you've ever sold anything on eBay, you know that 9 times out of 10 you'll get much more for it than you've ever expected. More than if you sell it on Craigslist. And then people go, well, I don't want to sell it on eBay because they charge me for it. Yeah, but you make up for it in how much more you sell the thing for. Because what ends up happening is the whole auction, you only have 5 minutes left, 3 minutes left, 4 minutes. People are more psychologically thrown off by the whole auction interface. They'll buy something just to get it. It's like a game. Some people will just bid to get it because they want it. And they'll pay more for it than if they just got out of that thinking, stopped bidding on that. Go to the store and buy it for cheaper and get it brand new over here. But it's the psychology of the website and the way that the website engine is hooked up and the way that the transactions actually occur promotes people to purchase. People want to buy. And it's the whole it has nothing to do, maybe it has nothing to do with the concept of what it is, but it's the whole psychology of using that website. So if you're going to build a website for your company, you want that. You don't want people to go away from it. You want people to buy at high prices all the time. And then when you buy, you always think, I'm going to get the lowest price. Sometimes it is the lowest price, or sometimes it's the availability. So I buy on there for the availability. If I can't find it in a store, I'll pay whatever I want to pay for it without thinking about it, just because I can get it, which is actually kind of an interesting phenomenon, because that person who has the product that I'm trying to buy, they got 1 million of it. They already have it. That's not their motivation. That's not what's getting them to buy it. So, call center metrics. Yeah, people who don't hang up, who actually wait. Which is actually kind of interesting. Well, the measuring success of the call center, the abandon rate, people hanging up, average speed to answer a call, answer a question. So they used to say that back when companies used to provide support, they had average wait times. Actually, you still get this. If you call well, actually, I can say there's one company in particular, the local Comcast or local telephone companies, cable providers, telephone companies, utilities providers are notorious for this because people will call them versus going to a website to get their questions answered, because it's having to do with a utility. If your service goes out, you're going to call them on the phone. So, long story short, extremely high abandon rate because people call in 5 or 6 times until they like the wait time, and then they'll stay. In the meantime, the wait time is actually calculated by how many people are currently calling in. So the wait time, 25 minutes. Whoa, why? And then all the people hang up. Now it's 0. Guess till those 25 people hung up already. But this is, again, and the reason why I'm bringing that, making that suggestion is, or making that observation, is that it's another, just like the website, it's a very hard thing to measure accurately. All right, now we're going to have attendance. So let me pause it. All right, let's finish this up. So we have call center metrics, as I was mentioning before, almost as difficult to measure as website metrics because they're almost as confusing. And there's also different tricks that customers play to get out of actually standing on hold or waiting on hold. So the random abandonment rate might be varied depending upon how long the wait is actually, which is actually kind of an interesting metrics to look at. Average speed to answer a call might be a good one. Might justify some of the other percentages that might be given. So call center metrics, again, the success of the call center efforts is what it's supposed to be measuring. So the time service factor. So it's generally measured in time. Also in first call resolution, answering questions and the ability of customers actually to get help and to get answers to their questions. So a lot of companies actually do the financial metrics because that's how they're basically going to be justifying any type of expenditures or investments or savings or something. So ultimately, IT systems must also make financial sense. Financial metrics are also called capital analysis or financial models, and many of them exist, and they're varied. It depends on what the purpose of the system is. So you learn about these in your other classes, but financial metrics are kind of an important thing for IT and for engineering kind of people to keep in mind. Here are, and these are what you get in management science actually, some of the different measurements techniques, and this is from either a quantitative business analysis perspective or from a financial investment analysis, so some sort of a calculation. And here's some classic formulas: your payback method, your cost-benefit ratio, your return on investment. Most people, know about this one because it's used a lot actually. Internal rate of return, another another metrics to look at in terms of that. So we're not going to really cover the metrics, and you don't have to know any metrics in general. You don't have to know how to count clicks on a website or measure abandonment rate on a call center or do any of the financial net metrics. But just basically keep in mind that they exist and that they're something that you want to look at. These are ways that you're showing that your investment in the infrastructure is making sense and that the company should like you and promote you and not fire you because you're spending a lot of money. What ends up happening in engineering actually over any other part of the organization is you guys spend the most money. Bottom line, you do spend the most money because you're buying the most expensive equipment and you're buying it for the company. So if you're not justifying why you're getting it and not showing the savings or any sort of benefit associated with it, then obviously there's going to be criticism. When people go, well, how can we spend so much money on IT? Or how can we spend so much money on the research part of it or this or that? Well, it's because of this. You have to come up with a this. If you don't come up with a this, there's no reason to spend it, really. So we also have this thing called a service level agreement, which comes out of this area as well. So formal contractual obligations, basically between the two parties. The service level agreement says how long are we going to support it. So you could be offering a service level agreement to the company if you're a consultant, or you could be actually honoring one or doing something if you've built a system for somebody else, depending upon which side of the business that you're standing on. But it's basically deals with both parties, both the buyer and the seller, and it guarantees some sort of level of satisfaction or some sort of level of commitment that you're going to continue to support it. So a lot of problem with outsourced companies traditionally is this lack of a service level agreement. So what ends up happening is you had somebody else build it for you, you bring it in, and then you have, like as I was mentioning last time, the tail light warranty. When they're gone, so is their service level agreement. So then a lot of companies fought back from that and said, well, you know what, we need some sort of guarantee that if it breaks, you'll fix it, or that if we get higher internet speeds, you'll improve it so it works with the higher speeds, or something happens. So then the entire agreement comes into place, and that's kind of a strategy in itself. If you study software engineering, one of the areas you could study would be metrics and also service level agreements and contracts and things. There's a whole business side to software engineering, actually. So the IT metrics and service level agreements, looking at the organization, we have an application service provider, an ASP, sort of like an internet service provider, an ISP, same concept exists, where you're not really going to sell them a system, you're just going to provide the system access in terms of an application. So in going through with one of them, you're really going to get some sort of a service level agreement. If your service goes down, you're not going to pay for it. It's kind of like what you get with the telephone companies or cable companies, actually. If you lose your cable, you don't necessarily have to pay for your cable for the days that you're missing it, or your cell phone. Did it just get cold in here? Like the air just came on. It's just like freezing now. Every time they turn the air on, it gets really cold. Anyway. The second focus of this lecture and today's lecture is on the business continuity planning and what that means. And it's another area. You could take an entire course in business continuity planning, just like you could take an entire course in telecommunications as well. But to give you the kind of summary of it by definition, rigorous, well-informed organization methodologies, developing business continuity plan. It's kind of like risk assessment and risk analysis, but this is for continuity, keeping the business going, keeping it running. Step-by-step guideline defining how the organization will recover from a disaster or extend from exist after a disruption of some sort. And so the disruption could be caused by the company, it could be caused by external factors, it could be caused by the economy, anything could actually lead to it. So it's a little bit more entailed than, let's say, a disaster recovery plan. So natural disasters, lights go out, fire, flood, or something. And that's kind of easy. What most people do is actually, if you just think back to the year 2000 or some of the earthquake preparedness stuff, the people in California are very skeptical. Well, they're very cautious about earthquakes because we have a lot of them in California. But long story short, what you could do is you have the earthquake preparedness kit, or you have a little kit you put in your car for when you break down in the middle of the road. You have your flares and your emergency water, or you have all your little things. Well, it's the same concept that a business has to do to make sure that they can continue. So if you're a bank, as an example, and your network system goes down, you don't just shut your doors. You can't. The cost or the risk of shutting the doors is way too high. So instead what you do is you have the manual processes. And so then people do things manually. They have a backup plan, essentially. They do a different procedure, a different process for taking and processing transactions. And then when the services come back online, they sync. They take the manual and they turn it into the automatic one. And they reconcile everything. Which is actually how tellers reconcile at the end of the day. At the end of the day, they count up how much money they have in their drawer, kind of like cashiers, and what were the sales receipts and how much, what was made, what was refunded, yada, yada, and then they balance out. So in your business continuity planning, that's the goal, is essentially to come up with it so that your salespeople aren't hindered, your manufacturing is not stopped completely, you haven't suffered a loss from it. So to prevent the loss, so it's really part of risk analysis as well. So business continuity planning, very important in today, given terror threats, increased climate volatility, volatile markets, not too stable out there. What happens when the internet goes down, or what happens when your product isn't going to sell or something. In terms of the methodology, we have the creating of the strategic plan, the analysis, the design, the implementation, the testing, and the maintenance. Looks like a life cycle model, and it is. It's a software development life cycle model, but it's not. It's a business continuity life cycle model. So coming up with a plan, analyzing what actually needs to be protected, designing the protection, implementing the protective mechanism in there, testing it, maintaining it, and continuously revisiting it is a cycle. So business continuity planning could be considered a methodology and a cycle, all in its same way. And very similar to software development, actually, software development life cycles. In terms of the concept, it's an extension off of the methodology, actually, used for that. So in terms of the organizational strategic plan, we have the analysis, the design, the implementation, the testing, and the maintenance. Organizational strategic plan is actually kind of interesting. You'd be surprised how many companies don't actually have an organizational strategic plan, but they should. And it's basically outlining the direction of the company, what their goals are, what they're accomplishing this year, next year, the following year. It's a strategic plan. So it all starts with a strategic plan, defines what's important, what's not important, gives you your critical success factors. And if your strategic business plan is created properly, you have your success factors. If you have your success factors and you focus on those, then the course of the business operation and the continuity will just continue and should grow towards its goal, theoretically, which is why people do strategic planning. So, must have a business continuity plan. So, for what is important. Who cares about what's not important, really? You don't need to worry about that. It's what's the critical success. So in terms of the analysis, you're doing an impact analysis or risk analysis. To say, what if what if we don't get our numbers, or what if we lose our power, or whatever happens to be the problem situation? Is it of importance? And what are the threats that are out there? What's going to take us down? Is it not necessarily just one threat? There might be multiple threats. After you've done your impact analysis and you've identified your threats, then you analyze the threats. Which one is the most important and which one's not the most important? Document all the possible major threats, and then do the impact scenario. If we are a business and we lose our suppliers, then we're going to need to do this. and have your worst case scenarios, your worst case planning for each one of your threats, which is kind of like a risk assessment in general, actually. And then you have your recovery document. So your business continuity plan works very similar to risk assessment, actually. What happens, and you have mitigation plans. So what happens when the risk actually happens, becomes a reality? Then you do this, this, and this. And then you have your choices. So identifies critical assets, threats to them, worst case scenarios, worst case plans. In terms of the design, you build the disaster recovery plan. And a detailed plan for recovering from the disaster might be maybe rented space and telecommunications equipment are all consolidated or collected or something. Or maybe they're moved. Or maybe the retail location is closed or something. Or maybe something's changed in terms of the facility or the operating, actually, the physical operation. Or maybe a hot site, so your fully equipped facility where your company can move to, jump to another location or something. Or maybe a cold site facility where the company can move to but has no computer equipment or anything to it. So, and this would be, let's say, for example, a natural disaster. So, yeah, it's kind of like, actually just think of yourself right now. If your apartment were to burn down, what's your business continuity plan? I don't go to the Red Red Cross shelter. They're going to be all full. Instead, you're going to, you'll have a list of numbers. That's what happens if you, when people travel a lot, what happens when you lose your passport? What are you going to do? Your credit cards, what are you going to do? In fact, a lot of people do pre-planning, and that would be considered business continuity planning or disaster recovery planning. So it all falls in the same kind of category. But businesses should do this. A lot of people forget that businesses are like people, actually. If they get their credit card stolen, then they're going to need to report it stolen. But what if they have a credit card protection plan or something? Then they don't have to worry about reporting it stolen. Or it's why people buy medical insurance or business insurance or directors and officers insurance. What happens if you get sued and you're a working an accountant? Actually, accountants worry about this all the time because they're working on finances. And they don't necessarily want to end up in an Enron situation, or they don't want the actions of the organization to reflect upon them personally. So they get insurance. And it's continuity planning. What happens when my company does something bad and I'm innocent? I have directors and officers insurance. It protects me. So it may not protect you in 100% of the cases, but sometimes it does. So the best disaster recovery plan in terms of the cost and time is the center point. The cost of the organization of recovering from a disaster over time, the cost of the organization of the unavailable or information technology. You find the medium, you find the cost curve. So it should include disaster recovery cost curve, which charts the cost of the unavailable information technology compared to the cost of recovering from the disaster over time. It's like your break-even point, because at a certain point, you're going to spend too much money on the business continuity planning, and you're going to slow everybody down, and you're going to cause a negative effect on the running of the business because you're so worried about business continuity planning. It's like the people that go traveling and they spend 1 month getting traveler's checks and getting a bunch of all this stuff and insurance and this and that. They spend all their time, and then they're gone for a week and they come back. And you're wondering, was it worth all that time and energy and expense to get all that stuff ready to go when nothing happened when you came back or something? Yeah. And so with the chances of something happening, they always look at that and they go, well, yeah, there's a bottom line. It's like the airlines, actually. Right now they're finding that bottom line. Is it really worth the expense of all of the infrared and the radar and everything else they're going to put in there to when they could probably catch people another way? Or maybe it's not that big of a problem anymore. Or maybe, so it's cost-benefit analysis as well. In terms of the implementation, engage any business that will provide any type of facility, hot sites or cold sites or backup. If you're a retail position, not an e-business or not like a, well, actually that would be an interesting thing for ITU. So if we talk about ITU for a second and a business continuity plan, what if we had a fire and the building burned down? Where would you sit in a classroom? What are we going to do? Will you reimburse your tuition? Where are we going to hold your class? I guarantee you we don't have a business continuity plan, so don't burn the building down. It's a brick building. It's not going to burn down. But, huh?
So you're asking us to do it?
No, don't do that. No, don't. You can't do it anyway. It's a brick building, it won't burn down. But if it weren't a brick building, if it were a wood building, the interesting thing and the example I'm trying to make is that our business continuity plan would have a couple of extra sites available. Say, if that were to happen, then we would move our classrooms across the street, or we would move them into this building over here, or that building over there. If that was part of our critical success factor, being able to provide a facility to hold a class in, that might be a problem if the facility goes away, which is actually kind of interesting when you think about it. Like, what if there's a water leak, or what if there's a this or that? So instead, you do preventative maintenance. You make sure that we have fire extinguishers. You make sure that we have properly running pipes and electricity and stuff. So, you know, for a retail company, that would pretty much put them out of business, actually. If their facility were to go down, you know, then essentially there's no customers. If there's no customer, it's like having a website and your web server provider goes down and your website's no longer available. That's going to cause a problem. Or your manufacturer goes away or something. So people that care about that, who plan ahead, do the business continuity planning. So denial of service attacks or something could cause a problem. So then you put up firewalls so you don't get that. So evaluating each IT system to ensure that it's configured optimally and recovered from a disaster properly as well. Then we have to test the system. That's why we have earthquake drills, and we have fire safety drills, and we have all of the things to test the system. If we had a problem, what would we do? You know, in the old days, they used to do this in hotels all the time, but they don't do it anymore. Now they just post signs. Now I see the signs are going away. They used to put it on the back of a hotel door, especially if it's a 3 or more story building. You'll see the instructions for evacuation, because eventually you're going to die if you get stuck in there. So there has to be, and there's only one way out of the building, and there's only one escape route or something, and one set of stairs because the elevators aren't going to work. So they usually, by law, they're supposed to tell you where they are. That's business continuity planning. Why? Because if you happen to die in the building and they didn't tell you how to get out, and it was their fault, then the company's really not going to exist very much longer after that, because they're going to be broke, because they're going to be paying for your wrongful death and everything else. So, not only that, they're not going to have any customers to go into the place anymore. They all died in the fire. Anyway, long story short, testing is good. So as opposed to a traditional software development lifecycle, testing of a business continuity plan occurs after the implementation. Can't really test it throughout. After you implement, see if the policy actually works. Have a fire drill. See if the people actually, they do this on boats all the time too, because boats are a problem. You know, there's only so many life rafts, and the life rafts are located somewhere, and life jackets are, and no, people aren't going to walk around with life jackets on all constantly. So instead they have a drill. Usually they have, if you ever go on a cruise, it's actually kind of fun. They do a run through on the business continuity planning. What happens if, and then it will always happen the first day because it's required by law. If you take a cruise in the United States, on the first day of the cruise, you will have a drill. The drill basically makes sure that you know how to put a life jacket on, essentially. And it makes sure that you can find where you're supposed to go, given your number, or where you're assigned a location. Can you find the location, and can you put a life jacket on? Because what ends up happening, and this has happened before, cruise ships sink, or they run into big things in the middle of the ocean or whatever, and they get into problems. Just like here's another thing, just when you fly. Every single flight you take will have a boring safety video or safety thing within the first 10 minutes before the flight actually, it's required by law, before the plane actually takes off. They must go through the safety video. You know, these are the exit doors, yada, yada, yada. In case of emergency, use your seat back as a flotation device, or blah, blah, blah. You know, I sort of remember it from all the flights I've taken, but that's a test. That's a testing measurement. So what banks do is they used to do it. I don't know if they still do it. I had a friend who worked at a bank, and he said that every month they had to spend an hour and do things manually, because what happens if the systems go down? They have to make sure everyone's still trained, and you know, here's the forms. They do it manually for an hour, then they spend the next hour putting it all back into the system after they've done it manually. So it's like how if you know, you are supposed to test things like fire alarm. Fire alarms are a good thing. They have a little button on it. You're supposed to press the button every month or so. Make sure the light turns the right color. Battery's good. Just in case you have a fire. Smoke alarm works. So simulate a disaster scenario. Have employees execute disaster recovery plans, and then evaluate success and refine as necessary. We had the plan, and nobody found the life jackets. Okay, there's a problem. So you need to give them better instructions. Or we threw the, in the hotel room. They used to do this in hotels. They don't do it as often as they used to. But they used to trigger the fire alarm to see what would happen. It's a nice little test to see if the people are actually going to evacuate. But the funny thing is you watch the commercials or you watch sometimes they videotape these things and you watch it and you look at that. There used to be a TV show that used to do that. In the case of an emergency, and you see a guy sitting like watching TV, eating, the alarms are going off, sprinklers are going on, and he's just watching TV. It's like, well, why aren't you moving? Oh, it's just a drill. He's like, how do you know it's a drill? Maintenance, performing testing annually at a minimum. Change the business continuity plan as the organizational strategy changes, different success factors, evaluate and react to new threats. Actually, that's the interesting thing is a lot of renters do this all the time. Brand new, rent a place, they get minimal renter's insurance. Then they go buy a bunch of expensive stuff, and they never upgrade their policy. So when the place burns down, then they're buying nice little flat screen and the leather sofa and everything gets ruined. Oh, you had $200 in renter's insurance? Wow. But that didn't cover all the nice things I just bought. So they don't change the policy. Businesses do it all the time, actually, with insurance. They only had 2 employees when they got the insurance. Now they have 100 employees. Uh-oh. I'm not going to cover it. No system is ever complete. It's an evolutionary process to go through. Anyway, that's the spiel on business continuity planning and the spiel on ERP systems. It's probably a good time just to stop for today. Give you guys a break from daylight savings. So, unless we have any questions, comments, or concerns, as I promised, we'll let you out a little bit early today. No? Okay, we're done for today.